Earlier on, we have actually seen the video on log equations where the bases are the same. So this time around, we're going to have the one with different base. And you realize that we have log 4 to the base 9 plus log x plus 4 to the base 3 equals to 2 log x base 3. Now this one is quite a, gives us kind of a good clue because this is base 3 and base 3. So it will be good for us to keep it to base 3, which means that we should change this to base 3. As a rule of thumb, usually we will try to change from the bigger to the smaller. So this will be the one that we're going to change to base 3. So we're going to employ the change of base. So what we're going to have is that we have log base 3, 4, and 9. Now for this one, no difference. And for this one, because eventually you may need to do some comparisons, so I'm going to use the power rule to bring up the 2. So I have log x squared to the base 3. Alright, so just get it off the way first. Now for this one here, now I'm going to try and simplify this. So 4 is the same as 2 squared, so I can have log 2 squared, this is base 3. 9 is the same as 3 squared. Alright, and no change for this, and no change for this. So let's simplify this. Using the power rule, the rabbit jumps down, so 2 will come down to the front here. So we have 2 log 2 base 3 over 2 log 3 base 3 plus log x plus 4 to the base 3 equals to log base 3 x squared. And from here you will see that the 2 and the 2 can divide itself out quite nicely, and log 3 to the base 3 is actually the value of 1. So this whole thing here, the only value that's left is log 2 base 3. Okay, I'm just going to copy out the rest because there's no change to it. Now, what we need to do is that we are going to compare terms on the left and right. So we try to make it such that the left-hand side has only one log term. So when we have 2 log terms and they have the same base, we can actually use the law of logs. So we are going to use the product rule. Okay, so in this case here, this is a plus, so it becomes a product. So we have log base 3. So I have 2 times x plus 4 is equals to log x squared to the base 3. So some students keep on saying that, we are cancelling out the log. We are not actually cancelling it out. We are actually comparing. So in other words, we are comparing this with this, right? So we have 2 times x, we have 2x. 2 times 4, we have 8. Is equals to x squared. So compare. Alright, so we don't have to bother about the log. It's just that when we have a base 2 on the left and the base 2 on the right, we compare the exponents. So it's the same concept. So you can see that it's almost like a quadratic. Okay, so let's just bring every term over to the same side. And this is what we'll have. And you realize that, hey, maybe we can factorize it. It's quite a nice number. So by using your factorization, this is what you will have. And by solving, you'll be able to get x equals to 4 or x equals to negative 2. Now again, check. Are both of these x values defined? Can we use both? It is possible that both are defined and we can use both, but there are cases where only one of them. Okay, so let's have a look. X can be either 4 or negative 2. Now let's look at our original question here. See here? Log x to the base 3. So this is x here, right? So this x here, for it to be defined, it cannot be negative. So we have to look at the original question. Alright, so do not think that, oh, because I have a square here, so eventually this becomes positive. No, we have to look at the original question. So if the original question had log x base 3, so we are looking at this x here. So if we put x as negative 2 into here, it is not defined anymore. Alright, so in this case here, we are going to reject this one here. So the only one that we will accept is x equals to 4. So always remember, do a check.